Next we shall see how to convert this skeletal equation into a balanced chemical equation. Balanced chemical equation means that equation will be having the same number of atoms of each element on both sides of the equation. So here in this case you start with the skeletal equation, which is H2 plus O2 gives H2O. 2 atoms of hydrogen present on the left hand side, 2 atoms of oxygen present on the left hand side, and with water 2 atoms of hydrogen and 1 atom of oxygen is present. So when we see the skeletal equation, we come to know that the number of atoms of hydrogen present is the same on both sides of the equation. What is it equal to? The number of atoms of hydrogen is equal to 2 on both sides of the equation. So we will start with atoms of oxygen. Since it is different, the number of atoms of oxygen is different, you start with oxygen. This is how you balance the equation. Start with oxygen. On the left hand side, 2 atoms of oxygen is present, whereas on the right hand side with water, only 1 atom of oxygen is present. So write it as LHS2 and RHS1. Now what we should do to balance? So we write to balance, LHS2 remains as 2 itself, whereas RHS1 should be multiplied by 2 so that we get 2 on both sides of the equation. This 2 should be taken only along with water. So we write the equation as H2 plus O2 gives 2H2O. Now again, after writing this equation, see the number of atoms of each element. Hydrogen on the left hand side it is 2, whereas with water 2 into 2, 4 atoms of hydrogen will be now present. Whereas oxygen, O2, in that you get 2 atoms of oxygen. With water on the product side, you get 2 atoms of oxygen. So oxygen is now balanced. The number of atoms of oxygen is the same. Now what has become different? The number of atoms of hydrogen has become different. So take hydrogen H. On the left hand side, LH is 2 atoms, and on the right hand side 2 into 2, 4 atoms of hydrogen. The number is now different. So to balance, how can you make this number the same on both sides of the equation? The left hand side 2 should be multiplied by 2 so that we get 4 on both sides of the equation. RHS4 remains 4. It remains as 4 itself. Whereas the LHS2 alone should be multiplied by 2. LHS2, it comes from hydrogen term. So this 2 should be taken only for hydrogen and not for oxygen. So when we take this 2 along with the hydrogen, we put it next to hydrogen. So it becomes 2H2 plus O2 gives 2H2O. Again, after writing this equation, check the number of atoms of hydrogen and oxygen. 2H2 means 4 atoms of hydrogen. 2H2O, 2 into 2, 4 atoms of hydrogen. So now we get 4 atoms of hydrogen on both sides of the equation. Similarly, check the number of atoms of oxygen. O2, 2 atoms of oxygen, and with water 2H2O, we have 2 atoms of oxygen. So oxygen atoms, the number of atoms of oxygen is also now the same on both sides of the equation. Thus 2H2 plus O2 gives 2H2O, represents the balanced chemical equation. So next we shall see how to write the balanced chemical reaction equation for the reaction of nitrogen with hydrogen to give ammonia. So to start with, you have to write the skeletal equation. The reaction of nitrogen with hydrogen. Nitrogen is again diatomic, so we write it as N2. Hydrogen is diatomic, so we write hydrogen as H2. So N2 plus H2 gives The product formed is ammonia. The formula of ammonia is NH3. So we write the skeletal equation as N2 plus H2 gives NH3. Now count the number of atoms of nitrogen and hydrogen on both sides of this equation. We get the number of nitrogen atoms as from N2, 2 atoms of nitrogen, and with ammonia we get only 1 atom of nitrogen. Whereas the number of atoms of hydrogen will be 2 atoms of hydrogen on the left hand side, that is the reactant side, and 3 atoms of hydrogen with ammonia. So here in this case the number of atoms of both hydrogen and nitrogen are not the same on both sides of the equation. So let us start with nitrogen. On the left hand side 2 atoms are present, and on the right hand side 1 atom of nitrogen is present with ammonia. Now how can you balance it? To balance, the RHS 1 should be multiplied by 2. So we get the equation as N2 plus H2 gives 2NH3. Say this particular equation N2 plus H2 gives 2NH3. In that, on the reactant side you get 2 atoms of nitrogen, 2 atoms of hydrogen, and when you write 2NH3, that shows 2 atoms of nitrogen and 2 into 3, that is 6 atoms of hydrogen. So even though the number of atoms of nitrogen becomes 2, the number of hydrogen will be now different. So the next step is to make the number of atoms of hydrogen the same. So next take hydrogen. The number of atoms of hydrogen on the left hand side is 2. With ammonia 2NH3, 2 into 3, 6 atoms of hydrogen will be present. So the numbers are 2 and 6. To balance, that is to make the number of atoms the same on both sides of the equation, in the case of hydrogen, 2 should be multiplied by 3. 6 remains as 6 itself. So now when you multiply it by 3, this 3 will be applicable only for the term hydrogen. So take the partially balanced equation which you have written. It becomes N2 plus 3H2 gives 2NH3. After writing this equation, again check the number of atoms of nitrogen and hydrogen. N2 means 2 atoms of nitrogen. 2 ammonia, that gives you 2 atoms of nitrogen. So nitrogen, number of atoms of nitrogen is 2 on both sides of the equation. The number of atoms of hydrogen, from 3H2 you get 3 into 2, 6 atoms of hydrogen. And in 2NH3, 2 into 3, 6 atoms of hydrogen will be present. So number of atoms of hydrogen is 6 on both sides of the equation. It is the same on both sides of the equation. The number of atoms of nitrogen is 2 on both sides of the equation. Thus the equation is balanced. N2 plus 3H2 gives 2NH3.